In the next exam question, we have two blocks of mass as 20 kgs and 5 kgs. They are connected by a light string called P. A second light inextensible string Q attached to the 5 kilogram block runs over a light frictionless pulley. A constant horizontal force of 250 Newton pulls the second string as shown in the diagram below. The magnitudes of the tensions in P is T1 and the tension in Q is T2. 2.1 then asks us to state Newton's second law of motion in words. Two point two asks to draw a labeled free body diagram of all the forces acting on the 5 kg block for a total of 3 marks. So remember, for a free body diagram, we use the dots with the vectors projecting outward. The 5 kg block has tension 2 upward, the tension T1 downwards, and gravity also working in down. Looking at the mark indication, you can see that you need to draw 3 vectors. 2.3 asks to calculate the magnitude of the tension T1 in string P for a total of 6 marks. Now, in order to solve this problem, we will have a look at both the force diagram of the 5 kilogram block as well as the 20 kilogram block. The values that we have already obtained or can obtain is T2, which would be equal to 250 Newton. The reason that they are equal is because this is a frictionless pulley, which means that the force over there would be equal to the force over there. The gravity we can calculate as mass times G, and we can do the same for the 20 kilogram block. Now, seeing as we have a constant horizontal force of 250 Newton, we can apply Newton's second law for both bodies. My direction of motion would be up positive and down negative. Since we have two unknowns in both equations, we can rewrite these equations in terms of T1. I can call this then equation 1 and equation 2. We can then first solve acceleration by setting equation 1 equal to equation 2. Now that we have obtained acceleration, we can solve T1 by substituting the acceleration into equation 1 or equation 2, which gives us a value of 200 Newton for T1. 2.4 says that when a 250 Newton force is replaced by a sharp pull on the string, one of the two strings will break. Which one of the two strings, P or Q, will break? Now, looking at the tensions, we can see that T2 has a value of 250 Newton, whereas T1 only has a value of 200 Newton. So if the force applied was replaced by a sharp pull, then T2 would break, seeing that the tension in T2 would be greater than that of T1.